This is a conductor. Like a metal wire, electrons, which carry a negative charge, flow freely in conductors. Metals are conductors and as such allow electrons to move freely through them. However, the electrons are not the only things found in metals or conductors. There are also other particles, such as atoms. Let's say the red circle with a negative in the middle is the electron, and the yellow circles are the atoms of the conductor. On a microscopic level, electrons moving through the conductor collide or interact with the atoms of the conductor. When they collide, electrons transfer their energy to the atoms. Electrons transfer their energy of motions to the atoms. The electrons therefore lose kinetic energy and eventually slow down. This leads to resistance. Resistance slows down the flow of charge in a circuit. Resistance is the opposition to the flow of electric charges. The electrons collide with the atoms of the conductor, causing them to vibrate faster and faster. So there is a conversion of kinetic energy of the electrons to vibrational kinetic energy of the atoms in the conductor. The faster the atoms vibrate, the hotter they become. This means when a circuit element resists electron flow, it heats up. You can feel this directly if you touch a cell phone charger when you are charging a cell phone. This is a circuit element called a resistor. A resistor opposes the flow of charge. This means resistors have a resistance. You will learn more about resistors in the second term. The circuit diagram symbol for a resistor is drawn like this. However, please note that resistors are not the only circuit elements which have resistance. Light bulbs also have a resistance. Remember, a light bulb is made up of a thin wire inside, which is surrounded by a glass housing. That small wire is a metal conductor with a very high resistance, meaning it opposes the flow of charge. It causes a lot of electrons inside it to slow down. The electrons transfer their kinetic energy to the atoms of the wire, and it causes them to vibrate. The faster they vibrate, the hotter they become. When atoms have become very hot, they give out light. And this is how old-fashioned light bulbs give out white light, allowing us to see in the dark. At the end of this lesson, you will be able to give a microscopic description of resistance in terms of electrons moving through a conductor, colliding with the particles of which the conductor or metal is made of, and transferring their kinetic energy. Explain that resistance is the opposition to the flow of electric charges. And define resistance as the ratio of the potential difference across a resistor to the current in that resistor. Define the unit of resistance, ohm. State and explain factors that affect resistance of a given material, things such as the temperature, the length, and thickness. And last, explain why a battery in a circuit goes flat eventually by referring to the energy transformations that take place in the battery and in the resistors in a circuit. We have explained that resistance is the opposition to the flow of electric charges, or the extent to which a resistor limits the flow of charge in it. The higher the resistance of the resistor, the smaller the current. This relationship is given by the following expression. R equals to V divided by I. The resistance R is equals to the potential difference V divided by the current I, where R is the resistance measured in ohm. The symbol for resistance is the Greek letter omega as shown in brackets. V is the potential difference in volts, and I is the current in amperes. This means you can also define the resistance of a resistor as the ratio of the potential difference across a resistor to the current in the resistor, V divided by I. We have said that the unit of resistance is an ohm, represented by the Greek letter omega. 1 ohm can be defined as 1 volt per ampere. So 1 ohm is equals to 1 volt per ampere. The resistance of a conductor can be affected by factors such as the type of metal, the length, the temperature, and the thickness of that conductor. A metal will have a higher resistance if its outer electrons are held more tightly by the nucleus of the atom. Resistance increases as the length of the resistor increases. This means the longer the conductor, the more resistant to electric charge the conductor is. Resistance increases as the temperature of the resistor is increased. This means the higher the temperature, the more resistant to electric charge the conductor is. Resistance decreases as the thickness of the resistor increases. The thicker the conductor, the less resistant to electric charge the conductor is. Before we finish, let us talk briefly about why a battery goes flat. A battery stores chemical potential energy. When a battery is connected in a circuit, a chemical reaction takes place inside the battery, which converts chemical potential energy to electrical energy, which powers the electrons to move through the circuit. All the circuit elements, such as conducting leads, resistors, and light bulbs, have some resistance to the flow of charge and convert the electrical energy to heat. And in the case of a light bulb, it is converted into light. Since energy is always conserved, the battery goes flat when all its chemical potential energy has been converted or transformed into other forms of energy. A battery goes flat when all its chemical potential energy has been converted into other forms of energy. We have come to the end of this lesson. We have learned that resistance is the opposition to the flow of electric charges. Resistance can also be described as the ratio of the potential difference across a resistor to the current in the resistor. 1 ohm is equal to 1 volt per ampere. A metal will have a higher resistance if its outer electrons are held more tightly by the nucleus of the atom. Resistance increases as the length of the resistor increases. Resistance decreases as the thickness of the resistor increases. Resistance increases as the temperature of the resistor is increased. And the battery goes flat when all its chemical potential energy has been converted into other forms of energy.